We have been told our whole lives that space is vast and mysterious, that somewhere out there, other planets exist, other worlds. But nobody told us they would look like this. A planet where it rains molten iron, a planet made almost entirely of diamond, a planet so dark it absorbs 99% of all light that touches it, making it literally blacker than coal. A planet being slowly eaten alive by its own star, and a planet with no star at all, drifting alone through the complete darkness of space for billions of years. These are not science fiction. Every single one of these planets is real, confirmed, peer-reviewed, documented by NASA, and they are only the beginning. Today, I'm going to take you on a tour of the most bizarre, most extreme, most mind-bending exoplanets ever discovered. Worlds so strange that they have forced scientists to go back and completely rewrite the rules of how planets are supposed to form. And the further we go on this list, the more impossible things get. So stay with me, because the last one shouldn't exist at all. Before we get to the worlds that will break your brain, let's establish something important. Every planet you learned about in school, Mercury, Venus, Earth, Mars, Jupiter, they all orbit our sun. They are part of our solar system. An exoplanet is any planet that orbits a different star, a star outside our solar system. For most of human history, we had no idea if exoplanets even existed. We could theorize, we could guess, but we couldn't see them. Then, in the early 1990s, we found the first ones, and since then, the number has exploded. As of today, astronomers have confirmed over 5,500 exoplanets, and that number grows every single week. Here is what makes this extraordinary. These are just the ones we can detect with current technology. Scientists estimate there could be trillions of planets in our galaxy alone. And what we've found so far has shattered every assumption we ever had about what a planet could be. Let's start with one that looks almost peaceful from a distance, almost beautiful, until you find out what its weather is made of. From space, HD 189733b looks stunning. It's a deep, vivid blue, like a giant sapphire hanging in the darkness. If you saw it through a telescope, you might think, that looks like an ocean world, maybe even a peaceful one. It is not peaceful. That beautiful blue color, it comes from silicate particles in the atmosphere, tiny particles of rock, superheated to over 1000 degrees Celsius, that become molten, and then in the upper atmosphere where it's slightly cooler, they solidify into microscopic shards of glass. HD 189733b rains glass, sideways, not downward like rain on Earth, sideways, driven by winds moving at 8,700 kilometers per hour. That is 7 times the speed of sound. Imagine standing in a glass tornado, every square centimeter of your body being hit by thousands of tiny glass needles every single second, at 7 times the speed of sound. This planet is located just 64 light years away, which in cosmic terms is practically our backyard, and it is one of the most studied exoplanets in history. Scientists recently used the James Webb Space Telescope to analyze its atmosphere and found something unexpected inside those clouds. The same chemical that makes rotten eggs smell, hydrogen sulfide. A beautiful blue planet, raining glass sideways at supersonic speeds, with an atmosphere that smells like death. And somehow that is not even close to the most extreme planet on this list. Because the next one doesn't rain glass, it rains something that should be impossible to fall from the sky. WASP 76b is located about 640 light years from Earth, and its day side, the side permanently facing its star, reaches temperatures of 2,400 degrees Celsius. That is hot enough to vaporize iron. Yes, on this planet, iron doesn't exist as a solid. It evaporates, it becomes gas, it floats into the atmosphere. But here is where it gets truly extraordinary. WASP-76b is what's called tidally locked. That means one side always faces the star, permanently baking in heat, and the other side, the night side, is in permanent darkness and permanent cold. Powerful winds on this planet carry the vaporized iron from the scalding day side across to the cold night side. And when that iron vapor hits the cooler temperatures of the night side, it condenses, it becomes liquid, and it falls. It rains molten iron on the night side of WASP-76b every night, constantly, permanently. Scientists confirmed this when they pointed telescopes at both sides of the planet and found iron vapor present on the day side, but completely absent on the night side, because on the night side it had already rained out. Think about what kind of world that is. One side so hot it melts metal into gas, the other side being rained on by liquid iron falling from the sky. And WASP-76b is not even the hottest planet we've found. In fact, the hottest planet on this list is so hot that it does something to its own atmosphere that even scientists found hard to believe. Here is a statement that should stop you in your tracks. There is a planet in our galaxy that is hotter than most stars. Not hotter than its own star, hotter than the majority of all stars in the Milky Way. That planet is Kelt 9b, and its dayside temperature reaches 4,300 degrees Celsius. Our sun's surface temperature, about 5,500 degrees Celsius. Kelt 9b gets almost that hot, and it's a planet, not a star. But the temperature isn't even the most bizarre part. At 4,300 degrees, the heat is so extreme that it literally tears molecules apart. On the day side of Kelt 9b, hydrogen molecules, the most basic building blocks of gas, are ripped into individual atoms by the sheer force of the heat. The atmosphere is being shredded constantly, and then, as those atoms drift to the slightly cooler night side, they reform back into molecules, only to be carried back to the day side and torn apart again. This planet's atmosphere is in a permanent cycle of destruction and reconstruction every single day. Kelt 9b orbits its star once every 36 hours, meaning a full year on this planet lasts less than 2 days on Earth. And its star, one of the hottest stars known to host a planet, is burning through its fuel so fast that scientists estimate it will expand and likely swallow Kelt 9b within a few 100 million years. A planet being torn apart by heat every day and being slowly consumed by its star over time. But what about a planet that is being consumed right now, not over millions of years? A planet that is actively falling into its star and will be completely gone within a few million years, and we can watch it happening. WASP-12b is dying. It is located about 600 light years away, and it is so close to its star that it completes a full orbit in just over 1 Earth day. 1 year on WASP-12b lasts 26 hours, but the closeness has a devastating consequence. The star's gravity is so powerful at that distance that it is literally stretching WASP-12b out of shape. The planet is being pulled into an egg shape, deformed by tidal forces so strong they're physically distorting its structure. And the star is pulling off the planet's outer atmosphere, actively stripping layers of gas away, creating a glowing tail of escaping material that trails behind the planet as it orbits. WASP-12b is being eaten slowly, continuously, visibly. Scientists have calculated that at this rate, WASP-12b has approximately 3 million years left before it's completely consumed. That sounds like a long time, but in astronomical terms, 3 million years is almost nothing. Humans have been on Earth for longer than that. We are watching, in real time, a planet in the final chapter of its existence, being pulled apart, being consumed, disappearing. And now, from a planet that is too close to its star, let's go to the complete opposite extreme. A planet with no star at all. A world drifting alone through the galaxy in absolute zero darkness, with no sun, no warmth, no light, forever. Imagine a planet formed billions of years ago around a star, just like Earth formed around our sun. But then, during the chaotic early formation of its solar system, a gravitational interaction with another massive object flung it out of orbit, kicked it away from its star like a ball being knocked off a table. And it just kept going into interstellar space, into the darkness between stars. No sun to orbit, no warmth, no light, no gravity anchor, just a planet drifting alone through the void. These are called rogue planets, free-floating worlds that belong to no star. And they are not rare. Astronomers estimate there could be trillions of rogue planets drifting through our galaxy right now. In fact, there may be more rogue planets than stars. Some of them are small, smaller than Earth. Some are the size of Jupiter. All of them are in complete, permanent darkness. The surface temperature of a rogue planet approaching absolute zero, minus 273 degrees Celsius. The coldest temperature physically possible in the universe. And yet, here is something that should genuinely surprise you. Some scientists believe certain rogue planets might still have liquid oceans, not from sunlight, but from geothermal heat generated by their own radioactive cores. And where there is liquid water, there is at least the theoretical possibility of life. Creatures living in complete darkness, on a world with no star, drifting through the galaxy alone for billions of years. The universe is stranger than we imagined, but we're not done yet, because the next planet on this list is one that scientists looked at and said, this should not be possible. By every law of physics we understand, this planet cannot exist, and yet, there it is. When light hits the moon reflects about 12% of it back. That's why we can see it glowing in the night sky. When light hits coal reflects about 4% of it back. It's dark, visually, one of the darkest natural substances we know. When light hits Tres 2b, it reflects less than 1%. TARES 2b is the darkest planet ever discovered. It absorbs 99% of all light that hits it. It is blacker than coal, blacker than any substance ever measured on Earth. If you were flying toward TRIES 2b, you would not see it coming. Even with your lights on, the planet would absorb them. You would fly directly into it, in complete darkness, and never know it was there until impact. Scientists aren't even fully sure why it's so dark. There may be light-absorbing chemicals in its atmosphere, sodium, potassium, titanium oxide, but the exact combination that creates this extreme darkness is still not fully understood. There is one faint clue that it exists at all. At its temperatures over 1000 degrees Celsius, it glows a very faint, barely perceptible dark red, like a coal ember that has almost completely cooled. A planet so dark it's almost invisible, glowing just barely, like the last ember of a dying fire. From planets that are too dark to see, let's go to a planet that is too light to believe. A planet so impossibly fluffy and low density that scientists genuinely cannot explain how it formed. WASP 193b is roughly 1.5 times the diameter of Jupiter. Jupiter is the largest planet in our solar system, so this thing is enormous. But here is what makes it one of the most confusing objects ever discovered. Despite being 50% larger than Jupiter in size, it contains only 14% of Jupiter's mass. Jupiter is dense, massive, powerful. WASP 193b is enormous, but almost weightless. Scientists calculated its density and found it is roughly comparable to cotton candy, a planet the size of 1.5 Jupiters with the density of cotton candy. How does something like that even form? How does a planet that size hold itself together when it's barely denser than air? The honest answer is scientists don't fully know. Current models of planetary formation cannot explain how WASP 193b came to exist. It is, by current physics, an anomaly, a giant, soft, impossible world, drifting around its star, defying our understanding of how planets work. And speaking of planets that defy understanding, the final planet on this list is perhaps the most mind-bending of all. Because it doesn't just challenge one rule of planetary science, it challenges the most fundamental rule of all. The rule that says a planet's size must make sense relative to the size of its star. In our solar system, the Sun is enormous. It contains 99.8% of all the mass in our entire solar system. Jupiter, our largest planet, is tiny by comparison. That size relationship makes sense. A massive star creates a massive disk of material when it forms, and from that disk, large planets can grow. Small stars create small disks. Small disks can only produce small planets. This is not just a theory, it is one of the most well-established principles in the entire field of planetary science. TOI 6894b breaks it completely. Its host star is a tiny red dwarf, roughly 20% the size of our Sun, one of the smallest types of stars in the galaxy. By every model we have, it should only be able to host small, rocky planets. Instead, orbiting this tiny star is a planet almost the size of Jupiter. Scientists announced this discovery in June 2025, and the reaction from the astronomy community was not excitement, it was confusion. Because this planet, by current theory, cannot exist. There wasn't enough material around that tiny star to build something that large. The disk would have been too small, too light, too thin, and yet the telescopes don't lie. There it is, orbiting a star a fifth the size of our Sun, a giant planet that physics says should not be there. Discoveries like this don't just add to our knowledge. They force us to go back to the beginning, back to the most basic questions, and ask, what else have we gotten wrong? Let's take a step back for a moment. We have a planet that rains glass sideways at supersonic speeds. A planet that rains molten iron every night. A planet hotter than most stars, where molecules are constantly being torn apart. A planet being slowly eaten by its own star, with only millions of years left. Trillions of worlds drifting alone through the galaxy, with no star, no light, no warmth. A planet so dark it's almost invisible, blacker than coal. A giant planet with the density of cotton candy. And a planet that, by everything we understand about physics, should not exist. More than 5,500 exoplanets confirmed. Scientists estimate there are trillions more we haven't found yet. And here is the thought that should stay with you tonight. We have surveyed only the tiniest, most microscopic fraction of the stars in our galaxy. The planets we've found so far, the glass rain, the iron rain, the impossible cotton candy giant, those are just the ones close enough and weird enough for our current telescopes to detect. What else is out there? What are the planets we haven't found yet? If the first 5,500 already broke the rules this many times, what happens when we find the next 5 million? The universe is not just vast, it is stranger and more creative than anything the human mind has ever imagined. And we are only just beginning to see it. Now, speaking of worlds that challenge everything, there is one planet in our solar system that scientists recently suggested might, just might, have signs of something biological in its clouds. Not confirmed, not proven. But the data was strange enough that it made headlines around the world. That planet is not Earth, and that story is next.